Welcome to Brain Vision.
All right, so for this problem, we're given the situation where there is a pendulum, a physical pendulum, that has a point A where it can oscillate, and it is a fixed position, and then there's point B, which can be at different locations, and when the pendulum is suspended from point A, the period of A is 1.80 seconds, and it is swapped and switched to be fixed at position B such that the period of oscillation for B is equal to the period of oscillation for A. Before we can, and what we're being asked to find is what is the length between A to B. What is that distance between A and B? So before we can get started with sorting through this, we have to figure out first what our moment of inertia is, what our rotational inertia is going to be. And we can use the equation period equals 2 pi times the square root of inertia divided by mass times gravity times height. And we're going to end up swapping out for inertia. We're going to be swapping inertia is equal to inertia at the center of mass for point A plus the mass height squared of position A, and then we're going to be doing the same with B, where HA, so we have the inertia is I center of mass plus mass times the height squared of position A, and then the inertia, so this is the inertia for A, and then the inertia for B is going to be the inertia at the center of the mass plus the mass HB squared, so the position of HB. And HA plus HB is going to equal the distance between our 2 points. So between point A and point B is L, or HA plus HB. So now that we have these terms, we're actually going to be substituting them back into this equation, and we're going to be going through a couple of different derivations here, so just stick with it. So first off, we can, because we know that the period of B is going to be equal to the period of A, and we have this equation here for our period, we can make them equal to one another. So in other words, I'm going to have 2 pi times the square root of I center of mass plus MHA squared divided by MGH is going to be equal to 2 pi the square root of ICM plus MHB squared divided by MGH. And then we can go ahead and simplify. Now we can divide both sides by 2 pi, square both sides, and we will end up with the equation I center of mass plus MHA squared divided by MGH equals I center of mass plus MHB squared divided by MGHB. So this is MGHA, that's MGHB. Sorry, I forgot those up here, A and B. And we can cross multiply, and that will give us our new equation. Once we cross multiply, we will end up with ICM MGHB plus MHA squared MGHB equals ICM MGHA plus MHB squared MGHA. And we're going to simplify this out quite a bit. So we would subtract this term on both sides, and then subtract this term on both sides, which would give us the resulting equation. I center of mass times MGHB minus MGHA equals MH squared B MGHA minus MH squared A MGHB. And we can simplify again and get rid of the mass and gravity from all of our terms, because it is in all of the terms, which will then give us the equation ICM HB minus HA equals MH squared B HA minus MH squared A HB. We can remove mass, so from all the terms, and put it outside, so we get H squared B HA minus H squared A HB. We can also remove an HA and HB from both sides, or from inside of our parentheses, so we would have mass times HA HB times HB minus HA, and that equals our ICM HB minus HA. And if we divide both sides by HBHA, we get a final simplified term of the inertia equals mass times HA HB. So this term, this equation, we can now substitute in mass HA HB for ICM. So going back up to our original equation we have up here, going back to this equation right here, we can substitute what we just found in for our ICM. So doing that, I'm going to end up with period equals 2 pi times the square root of MHA HB plus MH squared A divided by MGHA. And my mass divides out from all of it, and an HA is able to divide out. So my resulting equation comes out to be 2 pi times the square root of HB plus HA all over G. And as we said before, HA plus HB equals length. So I can change this to be 2 pi times the square root of length divided by gravity. Solving for length, I have length equals gravity times my period squared divided by 4 pi squared. So when I substitute in my values, I have 9.8 times 1.80 squared divided by 4 pi squared, and I get my final answer of length equals 0.804 meters.